After reading through this problem, this is quite the interesting problem. Where you're solving a rational inequality. So let's see. A landscape architect is designing a fence that will enclose a rectangular garden that has a perimeter of 250 feet. If the area of the garden is to be at least 1,000 square feet, write and solve an inequality to find the possible lengths of the fence. Ooh, doggies. Okay, well, let's see. All right, so we're given a perimeter. So the perimeter is equal to 250 feet. I'm going to end up trying to find possible lengths of the fence, and the area is at least 1,000 square feet. It means it could be greater than that, so we could say that it is, what would we say, greater than or equal to 1,000. All right, well, I want to do some things to make this work. Let's see, what is the perimeter other than 250 feet? So the perimeter is the length plus the width, and the length plus the width, or 2L plus 2W, right? Now what is the area? Well, the area is the length times the width. And I got to end up trying to find possible lengths. So let's see. Well, what if we take this perimeter of 250 feet equals 2L plus 2W. And let's solve for W, the width, and then substitute it into the area. How about that? Well, let's see. If I subtract 2L from both sides, I could then have that 250 minus 2L equals 2W. And then we can divide by 2. So 250 minus 2L over 2 equals W. All right, so the area's got to be at least 1,000. So I could then set this up as L times 250 minus 2L over 2 is greater than or equal to 1,000. Substituting what I saw for W over there. And let's see, actually I could go ahead and simplify this a little bit to 125 minus L. All right, well, let's distribute this L. So I've got L times 125, so we could say that 125L minus L squared is greater than or equal to 1,000. And let's see, if I moved everything over, I then could have this thing that 0 is greater than or equal to L squared, adding L squared to both sides, minus 125L plus 1,000. So 0, or y, is greater than or equal to L squared minus 125 plus 1,000. Now, if I could factor that L squared minus 125 plus 1,000, I might be able to find possible lengths for this fence. And with those kind of numbers, and something this tells me anyway, I might want to use the quadratic formula. So let's say we got negative b, or negative 125 plus or minus the square root of negative 125 squared minus 4 times 1 times 1,000, square root of that, all over 2. All right, so I got 125, so it'll be 125 plus or minus the square root of, what is 125 squared? 125 squared. That's 15,625 minus 4 times, negative 4 times 1 minus is 15,625 minus 4,000. And again, that's all over 2, all divided by 2. So then I've got 125. Let's put it right here. 125 plus or minus the square root of 11,625 divided by 2. And I think if I put all that into the calculator, that's going to give me a range of what the distance of the feet may be, because remember we got length times the width. I mean, so there's a lot that could go on there. All right, 125 plus or minus the square root of 11,625 divided by 2. I think I'm going to need a calculator to do this. What do you think? All right, well, I'm over here at the calculator. So let's just get to the math screen. Let's see what we have. I had 125. Let's do the plus the square root. I need to put all that in parentheses. Let me clear that. I'm going to put parentheses 125 plus the square root of 11,625. Get out from underneath the radical. Close my parentheses. Then we're going to divide that by 2. Let's see what that is. 116.4. So it could be as much as 116.4. And how about on the low end? So I'm going to put in parentheses 125 minus the square root of 11,625. Clear the radical, close the parentheses, divide by 2, 8.6. So the length of the fence, and remember, the length, no matter how small or how large it is, that's going to affect the width, since we already know the perimeter is 250 and the area's got to be at least 1,000. Could range anywhere from 8.6 feet out to 116.4 feet. And like I said, that was a pretty interesting problem. Sometimes you have to think, and thinking's good.